Good morning, everybody. So Shahid, you just want to move on to the first slide? So what we're going to do today, I'm going to quickly whiz over this because I know she needs to produce a really interesting demo for you today. We're going to go over basically what challenge languages are and kind of some of the background. I've done this a few times and I apologise to some of the people who've been to every single talk and they have to listen to the same thing several times. And then I'm going to hand over to Shahid. The rest of it's his show. He's going to kind of go over a bit of history, some live coding, which is always fun. Some of the pros and cons, and kind of some more resources for kind of, well, once you've seen this demo, if you're interested, well, what else can you do? And there'll be a few minutes for questions afterwards as well. So, okay, so just, do you want to move on, Shahid? The next slide, this is Shahid who will be talking today. He's a product developer and he'll probably give himself a little bit of an intro in a minute. This is me, I'm Jeff Watkins, I'm on Digital's chief engineer. I think over the years it's been very interesting to see how the industry's changed, and Digital, we are a kind of a technology agnostic consultancy, so we're always really interested in how the tech focus is shifting over time. So, so move on one. So for those who aren't familiar with Am Digital, we're basically a digital technology consultancy. We're about 750 people now, I think, with about 350 technologists. As I said, technology agnostic. It's one of the reasons why we're always looking for trends and accelerators in the market. So we help our clients navigate change, build the right products, and we also, while we're doing that, we help upskill our clients and the members of the community as well. So move on. Thank you. So we have three principal parts to And Guide, which is basically kind of our consultancy, which is effectively demystifying digital transformation, kind of coming up with strategies to actually sort of drive action in our clients. And then Build is the meat and potatoes around it's where we actually deliver digital products across a number of different technologies, a number of different all the major cloud providers. And Teach is effectively sort of our giving back to try and help build capability within our clients and our community. So through upskilling, through onboarding, both of which are award-winning parts of And. Thank you. So as Jessica mentioned, we're recording this webinar today. If you don't want to be recorded, please turn your video off. There might be some screen grabs. If you don't want to include in the screen grabs, please let Jessica know. So general code of conduct, we've had no problems with this on any And event. Just we want to make this a positive and safe environment. Everybody, all the speakers on this series have spent a lot of time on these demos, and obviously everybody's here wants to actually learn more about tech. So keep it positive. But I think it's we're really interested in diversity in the industry. So I want to make this a welcoming environment. So one of the other things is try and stay on mute during the talk, but I encourage you to, if you have any questions, type them into the chat pane. I will be monitoring the chat pane while Shahid's talking, and any questions I will narrate them at the end. If you have to dash at 11:45, that's fine. We might overrun by a couple of minutes, but don't worry, just if you want to go, you can go. So as you can see, this is the final one of the series. We left the best to last, one might argue. So we've covered a diverse set from Kotlin, Rust, TypeScript, and Go, and now we're in Clojure. So each one of these presentations, it does have a live element of demoing. So they always say never work with children, animals, and live code. So one of the things is like why we're discussing challenge languages. What is a challenger language? Here's the index of the most popular. This is the Toby index. Which is named after the Oscar Wilde play, The Importance of Being Earnest. This is the most popular by usage. I think it's lines of code and searches. So these are the most popular by usage in the world languages. And you see the C up there, and that's probably because you have to write quite a lot of lines of C to actually get anywhere, and obviously embedded. But Java is right up there, and C# and there's JavaScript. Interesting people have first asked why aren't we talking about Python in this series? Well, if you look at number 3 there, Python, one might argue that once you're number 3 in the world, you're probably not a challenger, you're probably up there. So really, and none of the languages we've mentioned here are in the top 10. So I mean, why are they chosen for this talk? If you see here, the most loved, there's the most loved and the most wanted and most dreaded from the Stack Overflow. So this is Stack Overflow 2020 survey, and you see Rust is up there, TypeScript is right up there, there's Kotlin and Go, Python's up there as well. Clojure is not far off this list. But if you see the actual languages we're using quite a lot, I mean, Java is not in there. JavaScript comes quite a lot lower than TypeScript. So really kind of, there's the intersection between what we love and what we actually do is not very strong. Thank you. So here's the most dreaded. Now, there's no surprise here that VBA is at the top, or Objective-C if you've ever used either of them, are kind of excessively ugly. We've got Java there. You know, Java, one of the second most popular programming language in the world, is sat there in the top 10 most dreaded. C# is just, I think it's like 11th. It's just pipped to the post in this list. So actually we're using things we really don't want to be using in some cases. So one of the things is, well, okay, there's a lot of languages, why don't we just choose one? You know, the actual answer is, well, there's a lot of context to using different languages. This is the final slide before I'll hand over to Shahid. Moving on. So, you know, we have different use cases for different languages. I mean, there's obviously different paradigms. Some are kind of imperative, some are declarative, some are object-oriented, some are functional. And we have the kind of use, well, some we want to run on bare metal, some of them we want to run, you know, compiled. Things like Go and Haskell and Rust, you can compile those. I mean, traditionally things like C and C++, and C compiles very well down into assembler. You have the old-fashioned interpreted languages, and the JavaScript once upon a time was strictly interpreted. It's kind of the lines are blurred a bit nowadays. And then we've kind of got the VM-based languages of the modern era, where this is kind of a write once, run many. So you compile into some kind of intermediate language or a bytecode or whatever you want to call it, depending on the virtual machine you're running. And this can be run on multiple different architectures. You don't need to rebuild for ARM or for Linux or for Windows. You know, it's write one once, run many. And each one of those in there, if you notice, even underneath, say, like JVM languages, they're very different, because Clojure is very different to Scala, which is very different to Java. So I think that's about all of the kind of context. So that's why, you know, there's obviously a number of different languages. Not all of them will fit every use case. So like you wouldn't necessarily use Go for much UI programming. So if you just want to move on, I think actually we're on to your content now. So without further ado, I would like to hand over to Shahid. Thank you very much, Shahid.
Thanks, Jeff. As Jeff described previously about the Clojure, I'm going to speak for this today, and it's one of the challenger language. I'm Shahid Azim, and then working in non-digital for about more than 1.5 years now as a product developer, and then got this opportunity to describe what Clojure is. Let's move on. Background is, it was invented by Richard Hickley, and it was released in 2009. So it's around like in market for about 11 years. First version was released in 2010. And the main goal was to initially create for the concurrent applications, because the multi-threading support was already in Java. But again, I think it wasn't really, like, you have to do a lot of things to get to that stage where you can do multi-threaded application. I think this is one of the things which they kept from the beginning to make applications concurrent. It's very simple and consistent, and it uses Lisp dialect. Simple and consistent means that is a functional programming language, and is using the Lisp dialect, which is slightly different as compared to the normal languages which we use. When I go do the demo, then I'll explain that exactly what those things look like. And then, as said previously, there are a few it is a functional programming language. So one of the use cases, functional programming language, immutable data structures is the default. basically most of everything is like immutable, because when you write code in functional programming languages, state is one of the key thing, and if you change it will create a new copy. So you can't really change. If you have to change something, you have to create a new copy of it, and that's what they get. If you compare it with other object-oriented languages, then the state is very well defined within the classes. But as I said, it is a functional, so it's a bit like difficult to maintain the state. Otherwise, it will introduce a lot of problems. So they kept it immutable, dynamically typed as well. At runtime, basically just pick the type, whatever you are passing. Concurrency support as previously described, and then the multi-dispatching as well. Multi-dispatching is like at runtime, you basically find what functions to call on which object, basically. So it, which is slightly not advanced, but slightly different as compared to polymorphic. So it's like a single polymorphic nature is that you have a object at runtime, you pick that what method to call on that object. But multi-dispatching, you don't even know the type, and then you basically call and you have a multiple functions where the types are defined, and then just pick whatever is the suitable method to call on objects. Hosted is it supports multi-platform, so it's hosted on VM, JavaScript, CLR. So it's just like you can run anywhere really, because that's the beauty of JVM. So you can use any platform you pick and you can run. JavaScript as well is one of them, and then CLR as well, it support now. Some of the use cases and uptake in the industry, it was started with concurrent programming, and then it just moved to a different area. So as you can see that the web is still most dominating area in this field. From the beginning is just like all the way up now is web. Open source, maths, enterprise, and commercial usage is heavily used. Yeah, enterprises are a bit like, it was a bit slow, because normally is the normal trend is that enterprise don't really take risk at a very early stage, but now it just got some momentum, and then it's basically currently in use. And then similarly, open source is from day one. Maths, there was initially very heavily used, but I think slowly it's just declining, but it's not really still in the list, still is in use. Commercial as well, same, I think so. The maths, commercial, enterprise are a bit on the same level. Uptake in the industry now, as you can see, that quite a few big brands are using it. Netflix, Walmart, Beanstalk, Go, ThoughtWorks, and basically, as you can see, quite a few names. And then if you search, there are loads and loads of other companies are using. Some of the anti-use cases are, yeah, there is always some merits and demerits as well. And same, Clojure is also facing some problems. So one of them is the hiring and staffing is the most frustrating part. Far from the mainstream programming languages and paradigms. As you can see that there's a Lisp dialect. Lisp is used a lot in the artificial intelligence. And then now those, to attract that community, Clojure was using the same thing, similar dialect. And then it's not a mainstream. So it could be one of the reasons that's why it's not there. But I think it's not really like, you can't really say that it's just only that, because it's a beautiful language, and then it's a functional, and it's very clean as well. So I think there will be a shift to adapt it. But again, that, yeah, languages are slightly different. It takes time to learn, but I think it's not really shouldn't really be an excuse. Tools are not mature enough. There is plugins are available. There are some like build tools as well available. But again, there is a very good support in IntelliJ example. For example, other IDs are supporting as well. Eclipse, you can write code as well. Yeah, but again, it's just not there. And then the lack of documentation as well. So sometimes, yeah, as I said, there is a documentation, but it's not really well enough. But there is a very good community behind it to support it. If you need any help, go into Clojure.org, and then you can find a community over there which is ready to help. Some of the features of this language is that, most loved language, best paid technology, nice and welcoming community, as said previously, and the only 1.5 of devs using it, and then the not much growth, and then the no new feature releases. So yeah, you can see that there is what trend is going, but it's not really like these are, maybe it's just mature enough language where not much required, but I think it depends on what is in the pipeline and then what is coming. We just need to keep an eye and then see that exactly what will come next on it. I think the next, I'll just give you some of the interesting frameworks and tools which are in use at the moment. As I said previously, it was used heavily in the web. So Ring is one of the web application library. It's basically inspired by Python's WSGI or Ruby's Rack stack. So yeah, so there is an very good framework to use to create the web applications. Composure is also a small routing library which work along, but basically is designed for Ring really to use. And if you basically want to pick an IDE, IntelliJ is nowadays very popular for Java development and Kotlin as well. So if you want to pick IntelliJ, yeah, so what you can use that. There is a plugin called Cursive, which is really good. I'm going to use the same plugin in IntelliJ, and then the yeah. So you can use in your IDs as well. You don't really need to go to VS Code, but there are plugins for VS Code as well, so you can use that as well. So the another framework and tools, one of the Clojure scripts as well. So if you have to create a front-end application, front-end library or front-end code in using Clojure, you can do that as well. There is a Clojure script compiler available as well. So you can write a code in a Clojure, and then by using Clojure script, you can compile that into JavaScript. It's a kind of like a transpiler, but the term they're using is compiler, not transpiler. So it basically about JavaScript, which you can use to create web applications. Clojure CLR is also if you want to run it on the .NET framework. So there is a project there as well, which you can use. Lanigan is also another build and automation tool. Is very good if you want to just create a quick application by using for Clojure. You can use Lanigan. Is really very good to quickly. It's just a dependency management. Any packages you want to add or remove or manage from there, and then build as well. So it just gives you a very quick start to run Clojure. Yeah, not taking further time, and then I'll just move on to the coding, and then we'll basically go through with some of the basic, what is a code really and how to write in Clojure. We'll cover that now. So I'm going to switch to IntelliJ, which is Android Studio, which is based on IntelliJ, and I'll give you some brief overview about that. I'm just dragging here. There will be a, basically we are going to use Android Studio or IntelliJ, both are same really. And then I'm using a plugin as I said previously. As you can see here, if you want to install it, you can install plugins, and one of the plugins, Cursive, is already installed, which I'm going to use. Just give you IntelliSense and all some of the execution part as well, how to run easily those scripts. I'm going to use the REPL environment where we just write and then run the commands. I'll give you a brief overview that how to start. So let's start with, I have split into a different section. We just cover the basic, then collection, and then some of the control structure, how, without going into much into the advanced topics. So if I just start this, so you just pick it and then start from here, and then it will invoke this REPL editor, and then you can basically write the commands here. As you can see here, the very first is very basic calculation. How to do it, just plus and then add. This is basically, as I said, is a Lisp dialect. So it's just like a slightly different. It's not really like 1 plus 2. You basically say that plus 1, 2, 3, 1 and 2. So if I just write here to press enter, then you get basically a result. That's the execution context here. And you can see that it's basically executed and then you get the results back. And then similarly, println function, use the similar calculation here. And then now I'm going to run from the direct editor. If I just set up a shortcut here, it's Command, Shift, and I to run the command directly. So I may write here as well, but I think I'll just keep on continuing like this. Println is a function we are calling, and then you're basically passing a variable. Any calculation, any variable, anything you really want to print something on the console, you can do that. Next is that keywords. If you want to define a keyword, you can do that. It's not like a do that, but the concept behind the keyword is that, especially in the maps, you use that. In other languages, you use string as a key, but if you want really a proper defined keyword, you can do that. The way to declare is any key. Any keyword is by using a colon sign and any name. So this will just become a part of your program. And then the symbols or keywords are same if they are same. Similarly, if they are two different symbols, then these are not really like a variables. These are just like a keywords or symbols. They don't contain value, but they just define some statement. Variables are, as we already know, that variable hold a value in a memory. So if you want to declare a variable, the syntax is def, def, and this will basically declare a global variable. Because you can, as it is a function language, if you have to declare a local variable, those are specific to functions only. Next, we are going to cover some of the functions and then how to define the local variables as well. Same here, I declare a variable called message and then it's contain the word hello. And then if I just want to print the value here, I can do that. Even you can write a println message, and it just display the message, whatever is holding within that variable. Similarly, you can define a variable by using a calculations. So, and then if you want to list it, then it will list it here. Now the next is the namespaces. Namespaces are, in any other languages we use, like if you pick Java, you define packages. If you pick C#, you define a namespace. Namespace is just like a logically separate your code from other part of the code to avoid collision for the names. That's why we use namespaces, because so Clojure also support the namespaces. And as you can see here that we are calling a function called lowercase, but this lowercase function is not declared within the default namespace where we are working at the moment. So we have to use, if we have to access other namespace, we have to use this notation. You specify the namespace and then / and then whatever you want to access from that. As you can see here, I'm calling this lowercase function, and then the result is coming in the lowercase, but we are accessing from a different namespace. You can declare your own namespaces as well. So the way is to like declare your namespace first, and then everything, whatever you define after that, it will come under that namespace. It's a very nice way to keep your code clean. So whatever namespace you want, just specify. There are certain rules that in terms of naming conventions, but you need to just make sure that you are just following that. I'm not going into much detail on that. The next is how, as Clojure is a functional language, and then without declaring a function doesn't make sense to describe a language itself, because so the two functions are a key strength of Clojure. And then I think the way to create is you use def and define name, and then your function name is, like in this example, you can say difference between two numbers a and b. So these are a and b are parameters to this function. And then you basically do a calculation. You can split into two as well. like is like this. You can do like sum, and then you say that okay, and then on the next line you basically say fn, and then name of the function, oh sorry, arguments here. So you can split into two, but I think as we normally do that, define a function with some parameters as well, just a single line, you can do that as and then again we are declaring a variable called result here. We pass the two values into it and then get the result and store into results variable, and then you want to print, and then the result will be listed here. So if I run this, it will basically declare a function or define a function. Sorry, I think so. Yeah, and then it will basically define this function, and then if we run it here, I think something. Yep, I think I switched to a different namespace, and I think that's why it was a bit problem. So it's back to normal now. So if I run this function, you can see the result 5 and 3. The difference is 2. The interesting thing is that we declare a new variable called result here, and then you can see here, if I just list this outside the function, you can see the value, which is fine sometimes, but I think sometimes you think that no, we don't want that function to be visible outside this function, because holding a memory, it should really get clear. So to avoid that, there is a statement, instead of using def, you use let. Let basically declare a local variables within that function. So that's the main difference between the local and global variables. So if I just do another version of this def, for example, and then if I, same result, but if I try to access this variable which we declared here, we won't get anything because it's not declared. The next stage is that the collections, any programming language has a set of collections defined in a library. Like if you pick arrays, for example, is one of the key collection used in every language. Vector maps, hash maps, you can name any. There are different variants as well, like sorted map, sorted list, and all these type of collections are there. So Clojure is also support inherited. You don't have to use keywords to define that what you're declaring, and then if you want to, you can do. There are two variations, like here is that if I use square bracket and then specify values, yeah, collection is declared and is an anonymous collection because we didn't store into a variable. You can define a variable, which I'll show you into another example. Similarly, if you want to use a vector keyword, same result, because you can use a keyword called vector and then specify values. Similarly, here is that the unordered list and unique list. There is another collection type called set, in which you basically define unordered but unique. You can't really have duplicate values. So if I just quickly run this, we're using, so the set is declared with the values 1, 2, 3, and then you can see that we are using a different notation here, curly braces. And if I try to do that, declare another one with the duplicate value, you will get an error. The way to declare by using a keyword is hash set. You can do that. Another most powerful collection in Clojure is called map, in which you store a key and value. So basically store a value against a name, as we previously looked into the keywords, and here you can see that the how is declared a map. So we are using a symbol called A and storing a value of 1 against that symbol of B and then 2. I'll use this example, another one, same thing, but the syntax slightly different. If you want to access a value from this map, you can easily by passing a key and then you get it from there. These are anonymous, we can't really do. In the another example, we'll have a look at how you can define a vector, for example, by using variable name. So if we are using the same notation def and say that, oh, I want to create a vector with name v, but in this vector I need 3 values. So once we have these details stored in a variable, and if I go and list v here, yeah, so you can see that all the 3 values are still there. Before, whatever the vectors or map and set I declared, those were anonymous, so I can't really access them. But now we can do certain operations on them. So if I want to access the value from v on a first index, for example, index starts from 0, so it will list 1. Similarly, first and last 2 methods are there, which basically give you capability to pick the last and first values from that vector. Quite handy. Conditional statement is also a slightly different way, because if in normal language, you basically specify like if and then condition. So if you want to use the conditional stuff, slightly different, but the result is same. So you basically specify if and then the what your expectation, what you want to check against, whether it's true or false, and then you specify the values. So if true, 1 and 2, which is not really, so it will return. So this is basically our condition, true to pick this or this. So this is basically condition we are specifying here, and then if it is true, then pick 1, otherwise pick 2. Similarly for false, and then you can even specify condition. Condition, you can see that here is slightly different. Is again the Lisp dialect is using greater than 1 and 2. So in this statement, if 1 is greater than 2, then what it should return, then definitely 1 is not greater than 2 to return false. One of the last control structure in the language is looping as well, in which basically you iterate on things, which is a Clojure also support that. The way to declare a loop is that you define the binding first, where you say that, okay, I want my binding is number start from 1, and then the condition is when the number is less than or equal to 10. Number is less than or equal to 10, and then basically these are the statement which we are doing this in this function. Literally not this one, last one, but the middle one, print, and we'll just print those numbers. And then if you want to recur, means is a recursion binding, which means that just to increment or decrement. So if you want to write a reverse loop, so you just implement in the reverse order, like subtract it. And definitely you have to change these conditions as well. So if I just run this loop, it's basically list all those values on the console here. Another thing I may not have mentioned, but there is no any like braces you use. You use basically indentation to describe the block of code. So you just need to make sure that I think it is similar to Python. So you just need to make sure that you indent properly, then those will come under that block of code, as you can see here. So yeah, so this is basically a brief, very, very brief and very quick as well. Apologies for that. Overview about the Clojure language. It's not really like, I'll move on to the slides and then just go on to the final one. It's not about that it's a very limited language. Is a different language. Yeah, every language is different, but it's a very well-designed programming language. And the main reason is the Lisp and also great community. And then there's a momentum as well. So if you really want to work on a functional language in a different space where you can use Java, JavaScript as well, and also .NET, you can use this language. And I think it's just like you write basically once your code, and then you can use a different runtime environments to run your code. For example, .NET Core, you can use Clojure CLR. If you want to run on JVM, yeah, you can use that. And there are some recommended resources here as well. Start with getting started, and then even you can follow this. This is very interesting as well from Heroku. You can deploy the web applications in Heroku Cloud as well. You develop in Clojure. You can even write your mobile app for Android and iOS with the Clojure script. So yeah, so I would really recommend you to go and then play yourself and try and then decide whether it's what to do with this language. Thanks very much.
Thank you, Shahid. That was great. So they've got a question in here. Does Clojure support interoperability with other languages such as Java?
Yeah, it is. It is very well. If you are running your program in, you basically write your program in Clojure and running on a JVM, you can easily access all the available libraries. Definitely, you have to do initial setup. There are tutorials available, but you can easily call without even writing those functions again or rewriting those again into Clojure. Yeah, definitely.
Okay. Alice is so. Why do you think it's that only 1.5% of developers use it at the moment?
I think is like it's in the market for about 10 years, and I think it's not really like a bad language. Maybe one of the reason is that the Lisp dialect, I would say, but that's the novelty about this language itself, really, because the developers, if you pick, for example, Java developers, they basically move to C# very quickly because the similarity between, but you don't really find them go and then try Python. There is a migration path to other languages, but not that. So I think maybe this is one of the reasons that the Clojure got that community, which was already working on Lisp, and then any new developers want to join this. Maybe.
Okay. I guess does Clojure run? I mean, you mentioned it runs on the JVM and .NET CLI. So I guess from a platform point of view, you could say it runs on most major platforms.
Yes, definitely. Yeah.
I think one of the other interesting things, just this came out in a question somebody asked recently, is you gave an example of loops and it recurses at the end. Loop, it does tail recursion, I guess, and that's actually kind of just this is an observation, not a question. Is like things like F# use a very similar thing, where they kind of they turn loops into, it's kind of a functional idiom. They turn loops into recursion, and if you did that in a regular language, you could quite, if you're counting to 1 billion, you could easily pop below the stack. But I'm guessing that Clojure does some kind of folding of that and actually turns it into a regular loop. I don't know if you know much about that.
Yeah, I think it's a slight, again, as you said, it's a slight different syntax, and yeah, you need to specify the right condition. Functional is just like you can even chain functions as well. So you are literally in your own function, you're chaining to a loop, which is also another function.
Cool. Any other questions from the floor? Cool. Well, thank you very much for your time today. And thank you, Shahid, for preparing a demo. And what is it? I'd say this is probably the most unique of the languages we visited during this series. We visited a number of different languages. And I'm almost sad it's at an end. I'm sure Jessica's not, because she's had to be through so many of these rehearsals. But it's wonderful. And thank you for everybody for coming along and showing support. But obviously we will be publishing these. You can stay on the line for a couple of minutes after other people leave if you just want to chat and ask other questions. I think that draws it to a close for today.